Good morning, students. Welcome you all for today's physics class. Yesterday we have gone through the table 1.1. There you all learned how to solve the dimensional formula, how to find the dimensional formula for all the derived quantities. And today we are going to discuss a new topic, that is principle of homogeneity of dimension. Principle of homogeneity of dimension. Principle of homogeneity of dimensions means what? What is the meaning of the word homogeneity? Homogeneity means it is a common word used to say the same kind, same for all. So that is what we are saying, the principle of homogeneity of dimension. Homogeneity means same. It means, suppose we have an expression, free-form expression, v square equal to u square plus 2as. This is an expression, physics expression. So if you are finding the dimension for each of these quantities, we will get all the quantity has same dimension. So that is what it is saying, dimension of all the terms in an expression should be same. Dimension in what? All the terms. Dimension of all the terms in a physical expression should be same. That is what we are saying, principle of homogeneity of dimension. It is very important, 2-mark question. You can mark in page number 30, principle of homogeneity of dimension. It means what? Principle of homogeneity of dimension states that dimension of all the terms in a physical expression should be same. I will show you how. You all know velocity dimensional formula. What is the dimensional formula for velocity? Yeah, Lt power minus 1. Lt power minus 1. Then equal to u. U means what? Velocity. So say Lt power minus 1 plus 2as. 2 means it is a dimension less quantity, so no need to use this 2. And a, acceleration. Dimensional formula is Lt power minus 2 into s. S means displacement, so length. Now put the square, here square, here also square. Now multiply this square inside, so what will get? Lt power minus 1 into 2. Minus 1 into 2 is what? Minus 2. Equal to, here 2 into minus 1. Multiply that again, t power minus 2. Plus, here L into L square. So L square, then what else? T power minus 2. So remember that here when you are multiplying 2 into minus 1, that is what? Minus 2. So here L is there. In that L also power 1 is there. So 1 into 2, 2. So here 2. Here also same, 1 into 2, 2. So you see, L square t power minus 2, L square t power minus 2, L square t power minus 2. So this is what we are saying, principle of homogeneity of dimension. It means what? Dimension of all the terms in a physical expression should be same. This is what here it is proved. One more fine example I will show you. You know the equation. V equal to u plus This is another equation, free-fall equation. So you know that V means what? Dimensional formula L T power minus 1 equal to U means L T power minus 1. V velocity, U also velocity, so L T power minus 1. Now plus A means acceleration, but is dimensional formula L T power minus 2. L T power minus 2. Then T. T means what? T. So here now L T power minus 1. Here L T power minus 1. Only here we have to do multiplication. L T power. Here minus 2 is there. Here 1 is there. So T power minus 2. Here plus 1. Minus 2 plus 1, what will become? T power minus 1. So T power minus 1. So you see, here plus is there. So you see again, this is on expression, physical expression. This is on physical expression. All the time, what are dimension should be same. That is what the principle of homogeneity of dimension. Now, based on this, already we have studied the dimensional analysis. Here, some of the applications are there. There are three applications. In that, the first application is convert a physical quantity from one system of unit to another system of unit. So that is what our next topic, page number 30, application and limitation of the method of dimensional analysis. So here we are discussing the application. First application is for the convert a physical quantity from one set of units to another set of unit. We have already learned so many set of unit. For example, CGS, MKS, FPS, SI. So these are the set of units we have learned already. In this set of unit, you can convert CGS to MKS, or you can convert one set of unit to another set of unit. Suppose it is you have given a value pressure in centimeter. We have one example, we will solve data. Pressure in centimeter is given. Centimeter means CGS. CGS means what? Centimeter, gram, second. MKS means what? Meter, kilogram, second. So 76 centimeter of mercury pressure. That is what example 1.12. We will solve. It is very important problem. 5 mark question. In many exams, previously in many exams, these questions asked. There are 4 examples in this unit, very important examples. In that, one of the 5 mark, very important 5 mark is example 1.12. It is based on the first application. Convert a physical quantity from one system of unit to another system. And the second application is check the dimensional correctness of a given physical formula. Already I did that principle of homogeneity. V is equal to U plus AT. You have to check whether all these terms you are getting the same dimension or not. That is what the second application. And the third application is establishing relations among various physical quantity. That we will discuss later. Some problems are there based on that. Now we are discussing the first application. What is first application? Convert a physical quantity from one set of unit to another set of unit. This is what for that just remember a small formula. N of u is equal to constant. N of u is equal to constant means this is what this is a product of a numerical value. So it is a product of numerical value and u is its corresponding unit. Suppose 76 centimeter of mercury means 76 centimeter of mercury pressure. 76 centimeter of mercury pressure. You have to convert into another meter, Newton meter square. Newton meter power minus 2. So you have to convert this 76 centimeter of mercury to meter. That is what application. Converting one system of unit to another system of unit. You are converting CGS to MKS. Now this is what this is what we are saying, this value 76. So that is what pressure 1. And we want to convert this 76 centimeter. Here we can write a CGS. So we have to write what centimeter, gram, second. So G means what? Gram means unit for mass. C means what? Unit for length. So yes, unit for time. So we can write this N of M L1 T1. This we can write N1 into M1 L1 T1. This equal to, you can write N2 into M2 L2 T2. This is what a small formula you remember. Small formula you remember. This is what here I am considering a physical quantity has a dimension of mass A, length B, and time C. That is what here just example A, B, C. Just example given, and this formula you remember. N1 into M1 L1 T1 equal to N2 into M2 L2 T2. So what is this N0? I told 76 centimeter of mercury, you want to convert it into Newton meter minus 2. So this N1 is pressure on this 76 centimeter. And what are M1, L1, T1, A, B, C equal to N2. N2. We want to convert. So we can keep it as P2. Then what are M2, L2, P2. A, B, C. So like this, we can convert from one set of unit to another set of unit. That is what our first application. And it is given in page number 30. You can go through page number 30, application of dimensional analysis. In that, first application is convert a physical quantity from one set of unit to another set of unit. That is what now I told. Now example 1.12. Example 1.12. It is very important problem. You must practice it. Once you have to watch this class. After watching the class, just pause your video and do it by yourself. So this will improve you, and it is very important problem. So you can see the question, page number 30, 1.12 example. Convert 76 centimeter of mercury pressure into Newton meter power minus 2. Use the method of dimension. So 76 centimeter of mercury pressure, you have to convert into Newton power minus 2. So it is very important. We can't convert this centimeter directly to Newton. Centimeter to Newton conversion, direct conversion is not possible. So first convert this 76 centimeter to dyne. For that 76 into 13.6 into 980 dyne centimeter minus 2. This is what the first thing you have to do. It is very important. 76 centimeter of mercury directly we can't convert into what? Newton meter minus 2. So first this 76 centimeter you have to convert it into dyne centimeter minus 2. So 76 into 13.6 into what? This is a value we have to multiply with 76. Then we can convert this 76 centimeter to dyne. Understand? Now you can go through. First you have to do this conversion. So 76 into 13.6 into 980 dyne centimeter minus 2. This is what the first you have to do conversion. Now it is given in the question using the method of dimensions. So first you have to write the dimensional formula for pressure. What is the dimensional formula for pressure? What is the dimensional formula for pressure? M L power minus 1 T power minus 2. So dimensional formula for pressure M L power minus 1 T power minus 2. You have to write like this: ml power minus 1 T power minus 2. Now we are going to convert this set of unit to that set of unit. For that you have to write the formula N1 M1 L1 T1 A B C equal to N2 M1 L1, sorry, here 2 T2, here A B C. This is what we can take pressure 1. What we can take pressure 1. This is pressure 2. We want to find out. So here you put P1 M1 A L1 B T1 C equal to pressure 2. We want to find out M 2 power A L 2 power B T 2 power C. Now we need to find out P2. So take this side, P2 M2 L2 T2 equal to, take this term another side, P1 into M1 power A L1 power B P1 power C. Now P2 equal to, keep this term P1 M1 power A L1 power B T1 power C divided by, take this term down, M2 power A L2 power B T2 power C. Now separate this, M1, M2 separate, L1, L2 separate, T1, T2 separate. So P2 equal to P1, you can write in a single bracket M1 by M2 Ka. So L1 by L2 B C T1 by T2. This is how you can separate and write down. So here AA is there, here BB is there. So I can take it commonly. In one step I am finishing. So A commonly. So here B is there, here B is there. That B only I have taken here. Here C is there, here C is there. That C only I have taken commonly. Okay. Now what you have to do means you have to find out the value for A, B, C, and we have to assume the value for mass 1, mass 2, L1, L2, T1, T2. That is what we are taking 1 unit. 1 unit. For example, you see first ABC value. Already here it is written dimensional formula for pressure. What is the dimensional formula for pressure? M L power minus 1 P power minus 2. This is used to take ABC value. So A equal to, A means what? Above M. Above M what is there? 1. So 1. B equal to above this L. So minus 1. C equal to above this T. What is there? Minus 2. So this is what the A, B, C value, A, B, C value. Now take on M1, M2 value. Here you can take M1 equal to L1 equal to T1 equal to M1, L1, T1 means what set of unit? What set of unit? CGS. CGS, centimeter, gram, second. So you take M1 is 1 gram. L1 is 1 centimeter. T1 is 1 second. Now M2, T2, L2, T2. M2, L2, T2 is what set of unit? MKS. So here you can take mass 1 kilogram, length 1 meter, time same 1 second. 1 second. Now substitute all these value in this equation. So take again this equation, rewrite this equation. P2 equal to M1. What is M1? 1 gram by M2. M2 is 1 kilogram. Power A means 1. Now L1 by L2. L1 is 1 centimeter. L2 is 1 meter. Here our value is minus 1. Now T1 by T2. T1 by T2. So what will come? 1 second by 1 second. Our value minus 2. Now you have to, you can cancel this 1 second 1 second. So the whole term cancelled. The whole term cancelled. The remaining P2 equal to 1 gram by 1 kilogram. Over 1. Then 1 centimeter by 1 meter. Our value. Now here what are P1 is there. Here what is there? P2 equal to P1. This P1 is there. Okay, don't forget that P1 is there. Now you have to write the value. P1 means what? 76 into 13.6 into 980. This is what? This is what? P1 value. Instead of P1, we have write what? 76 into 13.6 into 980. Then you have to convert this 1 gram to kilogram. You know the conversion, 1 gram to kilogram is what? 10 to the power minus 3 kilogram. So you can use that instead of 1 gram, 10 to the power minus 3 kilogram by 1 kilogram. Here centimeter meter 10 to the power minus 2. So 10 to the power minus 2. 10 to the power minus 2 meter by what? 1 meter. Power value here 1, here minus 1. Okay. Now kilogram cancel, meter cancel. What is remaining? P2 is equal to 76 into 13.6 into 980 into 10 to the power minus 3 into 1. Minus 3 into 1. What will come? 10 to the power minus 3. Here 10 to the power minus 2 into minus 1. Minus 2 into minus 1. What will come? Minus into minus plus. So 2 will come. So 10 to the power 2 will come plus 2. Understand? Now multiply this. Multiply this. When you multiply, you will get P2 is equal to 1, 0, 1, 2, 9, 2, 8. When you multiply 76 into 13.6 into 980, you will get 101, 2, 9, 2, 8. Now, into 10 to the power minus 3, 10 to the power plus 2, 10 to the power minus 3 plus 2. What will come? Minus 3 plus 2 is minus 1. Minus 1. This you have to write here. 10 to the power minus 1. Now, you see, as in physics, we always use scientific method. Scientific method. That means what? We write the answer by using scientific notation. So here decimal point is here. Move 1, 2, 3, 4, 5, 6. So you can write P2 equal to 1.01 into 10 to the power 6. 6 place we have shifted into this 10 to the power minus 1. Now 6 minus 1 is what? 5. So 10 to the power 6 minus 1 is 10 to the power 5. So you will get the P2 is equal to 0.01 into 10 to the power 5 Newton meter power minus. This is what example 1.12. Very important 5 mark question. You have to practice it. One more time I will tell you. First you have to convert the 76 centimeter of mercury, 76 centimeter of mercury pressure to dan. When we are converting into dan, 1346 into 980 will come. Now you have to write the dimensional formula for pressure. ml power minus 1, t power minus 2. Then we have to use the first application m1 L1 T1 N2 M2 L2. So here ABC. Then this instead of N0, that is what the product of numerical value and its corresponding unit. This is the product of numerical value. So 76 pressure 1, we know 76 here. Pressure 1. And N2 means pressure 2. We need to find out that. So then you know the calculation, we need to find out P2. So we are taking this P2 tan that side and that tan this side. Now P2 equal to what? You have to take this M2 L2 by T2 down. Cross multiplication, just cross multiplication. Now you see M1 M2. Here A is there. A is there, A is there. Take it commonly outside. L1 L2. B is there, B is there. Take it commonly outside. T1 T2. C commonly outside. Now this is what the dimensional formula for pressure. That is what in question. Use the method of dimension. So we are using. A means this m power what? 1. So A is 1. L power minus 1. So B is minus 1. T power minus 2. So C is minus 2. Now substituting in this formula. M1 is M1, M2 we have to take. So M1, L1, T1 means what set of unit? Centimeter, CGS. M2, L2, T2 means MKS. So 1 gram, 1 centimeter, 1 second. Here MKS. Meter, kilogram, second we are taking. Now substitute here. Now change this water. Change this gram to kilogram. That is what 10 to the power minus 3 kilogram. Centimeter to meter. So 10 to the power minus 2 meter. This is value for pressure 1. Now you see kilogram kilogram cancel, meter meter cancel. Here second already cancelled. Now multiply this, you will get this value. Here 10 to the power minus 3, 2. And you are adding minus 1 will get up. Change this decimal point. Write in scientific form 1.01 into what? 1, 2, 3, 4, 5, 6 into 10 to the power 6. Then 6 minus 1 is what? 5. So my dear students, you can refer the page number 30 and 32. It is very very important example problem. You can expect in public exam as well. So practice it. It is your homework. You have to do this homework as well as already from principle of homogeneity of dimension. Page number 30 itself. V square is equal to U square plus 2AS. The dimensional correctness, that also you practice it. Thank you. Bye bye.